In this video, what we're going to do is use the empirical rule to find percentages or areas under the bell curve. And one of the first things that I want to do here is draw that bell curve. So I'm just going to make a rough sketch of the bell curve here. If you really wanted something like a more accurate sketch, you could go online and just Google an image for bell curve. And then markings along the bottom, like print it and put some markings along the bottom, because that's the next step that we're going to do. So in the bell curve, the first thing I want to label here is in the center, I'll write the value of the mean. And according to the problem, the mean is 100. And then the standard deviation is 13. So what I do with that 13 is I'm going to make 3 marks to both the right and the left of the mean. Now there is a little bit of a science to this, how to make that mark, and it turns out that the first mark is where the curvature of the bell changes from concave down here to concave up here. So where that change happens, we call that a point of inflection, and I'm going to look down directly down here, and I'm going to make a mark that is 13 units different from the mean. So in this case, that would be 113. Now, if you don't have exactly where that point is, it's not too big a deal, because really what this picture is going to do is help us put an image to the empirical rule while we answer these questions about specific IQ scores. So I've now got a little bit of a sense of scale, so I'm going to try to repeat that scale. Notice I'm trying to keep about the same distance between tick marks to the right, and I'm going to continue to add 13 because there should be, this scale now represents 13 units. So 113 plus another 13 should be 126, and then plus another 13 would be 139. And at least this way now I have all the marks of first, second, and third standard deviation from the mean. Well, actually above the mean. I need to do the same thing below the mean. So 1, 2, 3 standard deviations. Again, roughly about the same distance. You could choose to draw in these vertical lines if you'd like or not. That's really a matter of preference. But this time, because it's below the mean, I'm going to be subtracting. So we'll do 100 minus 13, that is 87. That's the first standard deviation below the mean. Subtract 13 again, because remember, really these tick marks here are a scale of the standard deviation of 13. And then I'll subtract 13 one more time. And now I have all these values labeled on my bell curve, ready to go for the empirical rule. So what is the empirical rule? That is the rule that says 68, 95, and 99.7% of your data fall within 1, 2, and 3 standard deviations of the mean. So I'm going to do a lot of drawing over and then erasing as well, because it's kind of get really crowded here if I don't erase. So what I have here is that within 1 standard deviation of the mean. Well, let's think about what that means. Here's the mean. Within 1 standard deviation means to the right and to the left 1 tick mark. And then what the empirical rule says is all this space represents 68% of the data that you have presented here and within your problem. So in this case, 68% of people have an IQ score between 87 and 113. What the next number means, let me go back here. What the next number means, the 95, says that 95% of the data falls within 2 standard deviations of the mean. So of the mean, 1, 2 standard deviations to the right and to the left, that contains 95% of the data. And then the last one, again, that was 95. The last one, within 3 standard deviations, we have 99.7% of the data. So of the mean, 1, 2, 3. Oops, I kind of went a little bit farther. Let me back that up. 1, 2, 3. And 1, 2, 3 this way. That represents 99.7% of the area under the curve, of the data, related to the context of the problem. Now notice that's not 100% because technically this bell curve continues on and on forever, gets closer and closer to the x-axis. I did not draw that completely here, but there are these little pieces left on the tail end. Okay, so let me redo my sketch real quick. So now let's analyze what some of these questions are asking, where it says, what percentage of people has an IQ score between 61 and 139? Now, again, the nice thing about taking the time to set up your bell curve is you just identify where is 61, where is 139. Count how many standard deviations from the mean are you when you're at 61 or 139. It turns out both of these are 1, 2, 3, and 1, 2, 3 standard deviations away from the mean. So this represents all of this area and exactly 3 standard deviations from the mean in both directions. So the answer to that first part is 99.7%. And let's see here. If I go back to the question, oops, that's what we were supposed to put in. It does say type an integer or decimal, by the way. I can't see if that's all the way. Let me see if I can move that a little bit further into the screen. There we go. So for the next one, what percentage of people has an IQ score less than 74 or greater than 126? So let me go back again. Less than 74. Here's 74. And here are the people less. And that includes the tail that's not or outside of that empirical rule. And greater than 126. So again, that includes that smidge outside as well. Well, I don't have a direct empirical rule value for this area that I've shaded here in white, but I do have a value that represents what's not shaded. This is within 2 standard deviations of the mean. So in other words, this blank space here is 95% of our data. Well, if all of the data or all of the people would be 100%, and I want to take away the 95%, what I'm left with is the percent that's shaded in white, or in other words, 5%. So if I come back to my math lab, let's type in 5%. Okay, and now the last one, let me clean up my space a little bit here. So for the last one, the percentage of people that has an IQ score greater than 113. So we first identify where's the 113 along our bell curve. And see, now you can see why it's so handy to go ahead and just draw this entire bell curve. I want to find this area greater than 113. And again, that goes beyond even that last or third standard deviation. Now the 113 is marked on the 1 standard deviation mark. And there are a couple of ways I could go about this. I could say, okay, similar to the last example, this space within 1 standard deviation is 68% of the data. And I could immediately use symmetry, or I could later use symmetry. One way or the other, symmetry is going to have to be used because I'm only looking at one side of the bell curve. So let me show you both of those ways. So the first way I could say is, okay, I know that altogether there's 100% of data or people under the curve. I'm going to subtract what I know cannot be there, but I have a value for, and that's this 68%. That would leave me with 32% is left. But that 32% left is both the right and the left side. So this piece here in red, which I don't want. But because of the symmetry, I see that these areas, these spaces are equal. I could take that 32% and divide it by 2 to get what is in each part, both left and right. So 16% is over here, 16% is over here, and then I've arrived at my answer, 16%. I'll type that in here. But earlier I was just saying that I could do this and use symmetry a little bit earlier. So let me show you that method. Oh, that's as far back as it'll let me go. Okay, so if I use symmetry a little bit earlier, I still have to do something with the 68% because this mark of 113 is at the 1 standard deviation mark away from the mean. But I could choose to use symmetry right here, and I could break up the 68% into 2 parts. So 68 divided by 2 would be 34. In other words, 34% is on this side and 34% is on this side, but still within the space within 1 standard deviation of the mean. And you may even see images in your text that get this particular, like they say this is 34% instead of just using the 68. Everything to the left or to the right of this symmetry line would be 50%. So I'm going to look at just to the right. Everything to the right here is 50%. That is a 50, by the way. Let me fix that. Again, though, if I know that 34% is here and I don't want to include it, I would take 50% and subtract 34%, and I would be left with what is in white, this 16%. So that's another way to arrive at the 16%, but you use the symmetry at a different stage. So you'll find that as you get into more involved problems with the empirical rule and the bell curve, there is more than one way you could approach the problem. All of these, though, definitely use the empirical rule here, and they use this idea of area or space underneath the curve, and then some of the more advanced problems use that symmetry.